All right, so remember when we were doing rational functions and we talked about horizontal and slant asymptotes. Okay, horizontal and slant asymptotes. Remember with horizontal asymptotes, the majority of the time we never crossed or touched a horizontal asymptote, but I tried to emphasize the fact that it is possible to cross or touch a horizontal asymptote. It's just the main focus of a horizontal asymptote is it's describing what's happening at the ends. Okay, it's describing what's happening at the ends of the function. Slant asymptotes are doing the same thing. And then if we're not talking about rational functions, if we're just talking about a polynomial like example A, when we described its end behavior, okay, the left side was going this way, the right side was going that way. Those are just ways of describing limits at infinity without using the calculus term limits. All right, so here's the deal. In the future, questions like this in AP Calculus, questions like this are calculator inactive. Okay, you can't just look at the graph to be able to answer it. So I'm going to show you how to handle it without your calculator, but then I'm also going to show you, well, here's the graph, here's what's happening. You can always use that to figure it out. So when we're talking about a polynomial function in example A here, negative x cubed minus 4x plus 2, if we're talking about plugging in a really big number, what part of this function kind of takes over? What part of the function really matters? Do all three of those terms really matter if we're talking about plugging in a really big number, or is there one part of it that's more powerful than another part of the function? Is there a part x cubed? Is x cubed more powerful than just x? Yes. Is it more powerful than multiplying x by 4? Yes. Is it more powerful than adding 2 to that? Yes. X cubed here, this first term, the highest degree term, when we're talking about infinity, is the most important part. So if I am dealing with this without a calculator, I'm technically kind of going to plug in a number, but in this case, I'm plugging in infinity. So I'm going to kind of describe what I'm talking about. So I'm going to replace that x with infinity. Negative infinity in particular, because that's what my limit is approaching. Okay? So if I cube a negative number, what is the result? A negative number. Okay? If you cube a negative number, the result is negative. And I'm cubing infinity, so I'm just going to end up with infinity cubed. Okay? But then I multiply it by another negative in front there. So I cubed a negative and got a negative, but then I'm multiplying it by a negative. So this ends up being in like positive infinity cubed. So this limit is infinity. Now, I told you I was going to show you on the graph, okay, what's going on. So all you have to do is type in the function negative x cubed minus 4x plus 2. Zoom standard. Okay, so when we look at this, x approaches negative infinity. It's talking about which side of my graph, left side or the right side? The left. Negative infinity is the left side of my graph. On the left side of my graph, my y values are going up to positive infinity. Okay, so I showed you how to do it without the calculator, but the reality is on the final exam, you have your calculator. If they ask you a limit as you go to infinity, all you have to do is graph it and look at whichever side of the graph they're asking about. Okay, so that one's positive infinity. Let's look at a rational function. Okay, let's look at a rational function here. We've got negative 4x cubed minus 5 over 3x squared. Anybody remember what the horizontal asymptote to this one is? If the degree of the numerator is greater than the degree of the denominator, there isn't one. There isn't one. The top is bigger. This number on the top is really, really, really big. The number on the bottom is still big, but it's not as big. So overall, you're dividing a big number by a not so big number. Your result is still going to be a big number. Okay, the result is still going to be a big number. So if I'm trying to calculate this one kind of like I did the one before, again, I'm going to look at the highest degree stuff in the numerator versus the denominator, and I'm going to plug infinity in. Okay, so let's look at it here. I've got infinity cubed in the numerator and infinity squared in the denominator. If that was x cubed over x squared, what could we do? We could simplify that to just x in the top, right? X cubed over x squared leaves us with just x in the top. So this kind of leaves us with infinity on the top. If we're dividing infinity, the biggest number that we can possibly imagine, if we're dividing it by 3, does that really make it any smaller? Not really. Okay, because it's a massively huge number. Dividing it by 3 really doesn't make it any smaller. I mean, it does, but infinity can continue to grow. So this just ends up being, but there's a negative there, this ends up being negative infinity. So again, let's look at the graph, just to prove it to ourselves. Okay, plug in the numerator, and that negative is supposed to be in front of the whole thing. 4x cubed minus 5, make sure you have it in parentheses, over parentheses 3x squared. Don't forget to put parentheses around the numerator and the denominator of a rational function. Okay, look at the graph. Okay, x is approaching positive infinity, so that's the right side of our graph. Look at what the right side of our graph is doing. It's continuing to decrease. If you're not sure whether it's going to turn around or not, then just zoom out. Since we're talking about infinity, we can go out a little bit more, okay? But it's still headed down there towards negative infinity. Okay, this one doesn't have a horizontal asymptote, but what kind of asymptote does it have? It has a vertical and a slant. Okay, it has a slant because remember, when the degree of the numerator was exactly 1 degree greater than the denominator, it was a slant asymptote. See that diagonal behavior there? Okay, it's not leveling off horizontally. It's following that diagonal. It has a slant asymptote, okay? But the limit is negative infinity. It has nothing to do with the limit. I just wanted to remind you since we've forgotten. All right, last one here. The limit as x approaches infinity of x to the 4th over e to the x minus 3. Okay, so let's talk about this for a second. Which one's more powerful, x to the 4th or e to the x? Which one gets bigger faster? X to the 4th or e to the x? E to the x, okay? Exponentials always grow the fastest, okay? Exponentials grow the fastest. You've got logarithms are the slowest growth, then you've got polynomials, then you have exponentials. Exponentials always grow the fastest. So this denominator here is a lot bigger than the numerator. So if we're dividing by a really, really big number, what's the result? A small number. If the denominator is really big, 1/8, 1/24, 1/32, those are getting smaller and smaller and smaller, right? So this is essentially headed towards 0. So the only thing we have left here is the negative 3. But again, let's look at the graph. We've got x to the 4th over e to the x. If it makes you feel better, you can put parentheses, but you really don't need parentheses here. And then minus 3. Let's look at the graph as we're headed to, I should have zoomed out. But you can still kind of see it. Okay, look how it's leveling off here. We're talking x approaches positive infinity, so we're talking about the right side. It is leveling off. Let's look at the table to find out what value that actually is. We can tell it's negative, but we're not exactly sure what value it is. And pretty quickly, I mean, by the time we get to 10, 11, 12, we're already getting really close there. And then at 20, and from 20 on, it's going to say that the y value is negative 3. Okay, it's going to say that the y value is negative 3. So when you're talking about limits to infinity, typically you're talking about what part of the function is the most powerful. What is taking over? Because you're plugging in a really, really, really big number for your x. So which one's more powerful when you're plugging in a really big number? Well, e to the x is more powerful. Infinity to the fourth is really big, but e to the infinity is bigger. Okay? So that's making that fraction there very, very small. So the -3 is your indicator. Okay? Rational functions, the same thing. Is the top bigger or is the bottom bigger? Or are they the same? Okay? Or are they the same?